On question number 18, we have another trinomial one, and it's another one where we have different trig functions. So I want to have only one type of trig function. So I want to replace sine squared. We usually replace the squared one because we have our Pythagorean identities that allow us to do that. Okay, so this will be -7 cosine of theta is equal to 2 times 1 minus cosine of theta minus 5. Then I'm going to distribute that, and it's going to be negative cosine of theta is equal to 2 minus 2 cosine squared of theta minus 5. And this will be -7 cosine of theta is equal to -2 cosine squared of theta minus 3. So now I want everything onto one side. I want my squared term to be positive, so I'm going to move everything to the left. Okay, so now that everything's over there, I can factor this. And this will factor to be 2 cosine of theta minus 1 and cosine of theta minus 3 is equal to 0. So I set both of these equal to 0. And then I solve. So cosine of theta is 1/2. Cosine of theta is 3. So where is cosine of theta 1/2? Or where is the x value on the unit circle equal to 1/2? That would be here at 60 and here at 300. And then where is cosine of theta equal to 3? So where is x equal to 3? It's actually never on the unit circle equal to 3. So our answer is just 60 and 300. Again, if you kind of want to look at the graph for cosine, cosine again never gets bigger than 1 or smaller than -1. So a lot of times you'll have these branches where it's equal to numbers that are bigger than 1 or less than -1, and those branches just don't contribute anything. So only this branch contributes the answer. Okay, one more thing that I want to talk about is some variants on problems that could be asked, and that is the all solutions variant. So every solution that we have found has been in the first revolution. So if it's in radians, it's between 0 and 2 pi. If it's degrees, it's between 0 and 360. If, for instance, the question had been asked, find all solutions, then our process is almost exactly the same. We would first find all the solutions in the first revolution like we've been doing. But then we would put, then we'd add 2 pi k or 360k to each of our answers, depending on if it's in radians or degrees. And what this does is this accounts for all the coterminal angles. So if you want to add a revolution, k would be 1. If you want to add 2 revolutions, k would be 2. If you want to go in the negative direction, k can be negative, and you can subtract revolutions. But this would really account for all coterminal angles for those angles in the first revolution. So an example would be like number 13. When we solved it, we got pi over 2. So if the directions had asked for all solutions, then your answer would be pi over 2 plus 2 pi k. So the same thing, but we just put a plus 2 pi k to account for every single revolution. Another kind of variant on the problems is they could have been asked with a coefficient in front of the theta. So the process is the same. You'd first find the solutions, but then you would divide all of your answers by that coefficient. So on question number 1, we found that theta was 210 and 330. If the question was the exact same question, but you had a 2 theta, then you would find that 2 theta is 210 and 330. So then to get theta, you would just divide everything by 2. And your final answer would be 105 and 165. So the trig equations are basically the same. It's just that if they were to ask for all solutions, you would have these on the end of your problems. And if you had been asked a coefficient in front of the angle, you would have to divide by that coefficient.